Please stay connected. Do subscribe the channel. Hit the bell icon so that you get notified when the new video will be uploaded. Okay, and if the next part is uploaded already, then it must appear at the end of this video, at the end screen. Okay, just click there, then you get access to the. Then you will get access to the next video. Okay, next part, right? And if you want to follow me on Insta, this is my Insta ID, OJHALAKHYAJIT. This is my Insta ID 123. You can follow me on Insta. If you need the PDF of the PDF of this chapter, notes of this chapter. Okay, if you need the notes in the form of PDF, then you can send your phone number to this Insta ID. Just send me in inbox. Okay, then I will provide you the PDF of the notes of this lecture, not only of this lecture, of the whole chapter. Okay, so please do subscribe the channel, hit the thumbs up button, also share with your friends since I will create new contents for you, and don't forget to hit the bell icon. So do hit the bell icon so that you get notified when the new video will be uploaded, right? So now let's start. Suppose we have a conductor. This is a conductor of length L. Okay, and the potential difference across this conductor is suppose V. Okay, right? And the electric field across this conductor due to this potential difference is suppose E. We have considered E, and current flows through this conductor is suppose I. Okay, so now you see, so let me write, let L be the length of the conductor. L be the length of the conductor of area of cross section of cross-sectional area cross-sectional area is suppose A, right? So we have considered this cross-sectional area A. Okay, so V be the applied potential difference, across the two ends of the conductor, across the two ends of the conductor, right? Then electric field across the conductor will be given by length of this conductor, potential difference across it and divided by length. That's gonna give you the electric field, right? Therefore electric field across the conductor that will be given by E is equal to V by L. So hope you know this relation. Okay, so now you see, suppose let us consider that number of free electrons per unit volume. So let us consider the number of free electrons is suppose n. Okay, let n is equal to number of free electrons per unit volume. Okay, that is the number of electrons per unit volume. Okay, and if we consider E be the charge of magnitude of charge of each electron, its electron. Okay, then what will be the total charge in this conductor? So first let me find the total number of free electrons in this conductor. That will be given by volume of this conductor and number of free electrons per unit volume, right? So let me scroll down the page. Okay, now you see total number of free electrons will be equal to, if n is the if n is the number of free electrons per unit volume, then now you see, if the area of cross section of this conductor is A and the length is L, then its volume will be given by A into L, right? This is the volume, and volume into the number of free electrons per unit volume, that is NaL. This is the total number of charge, total number of free electrons, right? Free electrons, total number of free electrons, and charge of each electron is E, so that's why total charge in this conductor will be Q is equal to E into NaL, right? So hope you have understood this. Now let me write it properly. Okay, now you see what we can write: the total charge in the conductor is given by Q is equal to NaL into E. This represents total number of free electrons in the conductor, and this is charge of each electron, right? So hope you have understood this. So now you see time taken by the charge to cross the conductor. Suppose to cross the charge takes, suppose time t to cross this conductor. So now you see time taken by, how to find it? Time taken by the charge to cross the conductor length is, now you see, suppose this is the conductor and drift velocity of free electrons be, suppose Vd, if we consider Vd, and this is the length, and so time will be time taken to cross this conductor will be given by T is equal to L by Vd, right? So hope you have understood this. So that's why T is equal to L by Vd. So Vd is the drift velocity. That means this is the, suppose when electron, that means drift velocity means a free electrons, the velocity with the average velocity with which free electrons drifting, it is drifting along its length. Okay, that is the drift velocity, right? And drift then L by drift velocity, that will be given that will be time taken by the charge to cross the conductor length. Okay, so hope you have understood this. This is, suppose let me take, this is equation number 1, this is equation number 1, and this is suppose equation number 2. Okay, now electric current I is equal to Q by T. Charge flows through the conductor per unit time, that is Q by T. Okay, if total Q amount of charges cross the conductor in time T, then that will be given by Q by T. And So let's put the value of q from equation number 1. Okay, from equation number 1, n a l into e divided by t. Let us put the expression of t from equation number 2, that is L by Vd. So here we're going to mention that Vd is the drift velocity. So we're going to mention where Vd is the drift velocity. Sorry, let me write it properly. Drift velocity. So Vd is the drift velocity, right? Now you see, here we have used equation number 1 and 2, using 1 and equation number 2, right? So if you simplify this, then what you're going to have, then this L cancels. So that's why we can write I is equal to NEA V into D. So this is the relation between drift velocity and electric current. So this is the relation between drift velocity and electric current. Let it be, suppose, equation number 3. This is what relation between drift velocity that is Vd and electric current that is I. Now what will be the relation between this electric current and electric field? Okay, let us obtain that one also in terms of mobility. Now we know that that mobility mu is equal to Vd by E. We know this relation. In the last lecture we have already discussed about that. So from here we can write Vd is equal to mu in terms of into E. Okay, so therefore if we use this equation, suppose this is equation number 4, if we use this in equation number 3, then what we're going to have, so from 3 and 4, from equation number 3 and from equation number 4, we're going to have I is equal to NEA. Instead of Vd we're going to write mu E. So this is the relation between electric field and electric current in terms of mobility, mu. Okay, so similarly we can obtain another relation. So we also know that that drift velocity Vd is also given by E, capital E, tau by m, where m is mass of each electron, right? So if we replace this Vd by this value, then what we're going to have, then from 3 we're going to have this relation Ne square A E tau by m. So we're going to get this relation. How? We have replaced this Vd by this result, right? Hope you have understood this. Okay, now you see, just give me a second. Okay. So this is another relation we have got. Okay, now let us discuss about Ohm's law. So this is the statement of Ohm's law. Now you see, the current through a conductor, this is a conductor, the current through a conductor is directly proportional to the potential difference across this conductor. Okay, the current through this conductor is directly proportional to the potential difference across the conductor. So V and I, these two are directly proportional, so we can say V proportional to I. So if we write equal sign, we need a constant of proportionality, let it be R. Okay, so this constant of proportionality is called, in this case it is resistance. So R is the constant of proportionality is called resistance, and its SI unit is ohm. Its SI unit is ohm. So this is the Ohm's law, right? This is the mathematical expression. Now you see, the resistance of a conductor depends on its length, also depends on its area of cross section, right? And this resistance of this conductor is directly proportional to its length and inversely proportional to its area of cross section. Okay, so the resistance of a conductor depends on the length of the conductor okay, and its area of cross section. Area of cross section. Okay, now you see, and it also depends on the material of the conductor. I will explain how. Now you see, so we can say R is proportional to L, where L is the length of a conductor of cross-sectional area, suppose A. So then R is inversely proportional to the area of cross section. Combining these two, we can write R varies as L by A, right? L by A. So now you see, let me mention. So if V be the potential difference across a conductor, okay, and I is the electric current through the conductor. Then V is proportional to I, so V is equal to Ri. Okay, so now you see, so here also we need constant of proportionality. Here in this case it will be rho. Rho depends on the nature of the material of the conductor, which is known as, this rho is known as resistivity. This is known as resistivity or specific resistance or specific resistance, and its SI unit is ohm meter. Okay, and its reciprocal is known as, conductivity. Okay, so we're going to mention it later. Okay, now you see, from Ohm's law, that V is equal to IR. Okay, from Ohm's law, V equal to IR. So if you put the value of R here, now you see, just instead of writing that way, let me use equation numbers. Here you see, so this is suppose equation number 1, and this is suppose equation number 2, right? So from 1 and equation number 2, in equation number we have V is equal to IR, right? V equal to IR, and equation number 2 we have R is equal to rho L by A. So if we replace this R, okay, by this value, then what we're gonna have, then from 1 we're gonna have V is equal to I into rho L by A. That's what we're gonna have. Okay, so now you see, we know that if this is the conductor, if we apply the potential difference across this conductor, that is V, and its length is L, then electric field E is given by V by L. So that's why V will be equal to E into L, right? So that's why what we can say, that V is equal to E into L rho I L by A. Here we're gonna write, since here we're gonna write electric field across a conductor of length L, when instead of that, let me write electric field across a conductor of length L is E is equal to V by L, when the potential difference across the conductor is V. So that's why we can write V is equal to E into L. So if we write that, then what we're gonna get, this L cancels. So that's why we can write that E is equal to I, let me write the rho first, I by A. That's what we can write. Now you see, here we have got another quantity, that is I by A. Okay, I by A. This I by A is nothing but the magnitude of current density is equal to I by A. This is what magnitude of current density. So that's why we can write that E is equal to rho into J. Okay, rho into J. So J is the magnitude of current density J vector. So here you see in vector form, this E vector, because electric field is a vector quantity, rho into J is also a vector quantity, and direction of J is along this electric field, right? So hope you have understood this. So this is one very important relation. So this relation was asked to derive in 2024 Assam Higher Secondary ACES final examination. Not only 2024 or 2025. Okay, final exam under Assam Higher Secondary Education Council, right? This was asked in 2025 this year. Okay, so now again here let me introduce one more quantity, that is called conductivity. Conductivity, sigma is reciprocal of resistivity, is called conductivity. Okay, so we know that the unit of resistivity is ohm meter. So since the conductivity is reciprocal of resistivity, so its SI unit of conductivity, ohm inverse meter inverse, right? So hope you have understood this. So this is one very important relation, remember this. So therefore the above equation, this equation also can be written this way. Therefore electric field E is equal to 1 by sigma, because if sigma is equal to 1 by rho, then rho will be 1 by sigma into J. That's why this implies J, that is current density, is equal to sigma into E. So this is a very important relation. Okay, this is also a very important relation. Okay, so this was asked in this was also asked in 2025. Okay, right? ACES final exam under Assam Higher Secondary Education Council. Okay, this is also a very important result, right? This is also very important. This was asked in 2025. This was also asked in 2025. So now here you see this relation is called vector form of Ohm's law or microscopic form of Ohm's law. Microscopic form of Ohm's law or vector form of Ohm's law, right? So hope you have understood this. Now you see, we know that the relation between the drift velocity and electric current, let me write this way. We know that the relation between drift velocity and electric current is, that is already we have derived here. You see this one, this relation, equation number 3 is I is equal to N E A V D. Vd is drift velocity, right? And I is electric current. N is the number of free electrons per unit volume, right? And A is the area of cross section of the conductor, and E is the charge of each electron. Right? So hope you have understood this. Okay, so you see, we know that magnitude of current density, this J is called current density, right? So I think I forgot to write here. Okay, this is current density, I have mentioned here. Okay, so we know that J is current density, which is given by magnitude of current density is given by I by A, right? I by A. So I is NEA VD by A. So A cancels. We're gonna get NEVD. So in vector form, if we want to write this, current density is equal to NEVD. Here we're gonna write vector symbol. Okay, this is also a very important relation, right? Now you see, we know that VD, VD is equal to E, capital E, tau by M. In the last lecture, we have discussed about this drift velocity. We have derived this relation of drift velocity. If we use this relation here, then what we will have, okay, then we can have J vector is equal to NE square, capital E, tau by M, right? And this relation, this was asked in 2024, okay, HS examination, final examination, 2024 HS final exam under Assam Higher Secondary Education and, sorry, let me write it, Higher Secondary Education Council. Again, you see, we have already shown, we have already got that J is equal to sigma E. Okay. So let me, okay, this one, right here. Okay, J is equal to sigma E. So we're gonna have NE square E vector tau by M. Here we're gonna write, since J is equal to sigma E, which is the vector form of Ohm's law. So here this E cancel, so we're gonna get this E cancel, so we're gonna get sigma E is equal to N small e squared tau by M. That's what we're gonna have, right? This is one very important relation. This was also asked in 2024, right? Let me use the reading here, 2024 Assam Higher Secondary Educational Council. Okay, so from here we also we can also derive for an expression for resistivity. We know that resistivity is nothing but a reciprocal of conductivity, so that's why we can write resistivity is equal to, so reciprocal of this expression will be m by n e square, also a very important relation. And one more thing, we know that R is equal to rho L by A. If we replace this relation, replace this rho by this result, then what we're gonna get? R is equal to ml n e square tau A. Okay, this is also a very important relation. This was also asked in 2024. Okay, 2024 HS final. Under Assam Higher Secondary Educational Council. So hope you have understood this. Please do hit the thumbs up button if you like my video, then do share with your friends, inspire me to create new contents for you and help me to grow my channel. So thank you for watching my videos, and stay